Hello everyone. So to all the students, because who are about to write CBSE board exams this year. So I think the CBSE board exams are starting around the month of February, uh, and it will go till the month of March. So what is most important right now is to understand that how to attempt a paper. So many students have requested us. They were kind of scared because they keep on getting different funda, different knowledge, different gyan from people that how to write how to basically represent their paper in the board examinations. In fact, there is some student who asked me, sir, if I do not start my sentence with a capital letter in maths, will my marks get deducted or not? So I told that when they are writing math paper, it's not that important that they whether they start the sentence with capital letter or small letter, because it's not an English paper. So we are going to start a wonderful series for all the students because we got multiple requests. So we'll have daily master classes for all the chapters. We will be covering some part of theory, and then after that we'll be looking at chapter from the lens of board exams. So we will go through the last year board papers. We will take up the questions chapter wise. We will see that what exactly is the marking scheme, how much is exactly required to write in an exam paper, whether you should write with colorful pen, whether all that is required or not, for which step you get what marks, rather than saying that yes, there will be steps marks. So we are going to deep dive chapter by chapter. So daily we'll be releasing videos to help all of you out who are about to write their CBSE board exams in another 4 months, 3 to 4 months. So these videos are going to be very crucial. We'll be covering all the chapters. Then we'll have separate videos at the end to see how to take case study type of questions, how to do time management, how to ensure that you get your best out of those 80 marks in mathematics. So without any further delay, we'll start with our first chapter that we'll be doing in this video. So the chapter that we are going to cover, the first chapter in this video will be relations. So we'll start out with our first chapter, that is relations. All right. So as we have been discussing that this entire series is going to be in such a way that we'll cover a little bit of theory and then trial will see how to attempt, how to write a paper so that we make best of our knowledge. So coming to the theory part of relations. So the first chapter is relation and function, but we'll be breaking this down into two parts. In today's video, we'll be looking into relation. Tomorrow, we'll be talking about functions. So in relations, the important part is basically we need to understand that what is Cartesian product. Although the introduction of that already happened in your grade 11. So for two sets, if I have a set A and B, its Cartesian product is A cross B. And if let's say a set A have elements 1, 2, and 3, and set B have an element A and B. So the Cartesian product will be nothing but set of ordered pairs. So it will be in the form of 1 comma A, 2 comma A, 3 comma A. Then we'll have uh, 1 comma B, 2 comma B, 3 comma B, and so on. So we'll have total these 6 elements. So that's how we talk about Cartesian product. Now, what's the relation? Relation is simple. We say that relation is nothing but a subset of the Cartesian product. Maybe I'll add a new page over here. All right. So what's the relation? Relation is nothing but it's a subset of Cartesian product. So it's a subset. It's a subset of Cartesian product. It's a subset of Cartesian product. So if in case we come across a question where we have been asked that how many relations are possible, how many relations are possible, how many relations are possible. So basically we are saying that how many relations are possible of the Cartesian product, that is A cross B. Now relation are nothing but a subset. So the total number of possible subset will be total number of possible relationships. So if we add the null relationship, because null set will also be a subset of that, we can say that the number of relations are from set A to set B will always be 2 to the power k, where k is what? K is the number of elements in the Cartesian product A cross B. Now then again, this includes the null relationship as well. So, but that's how we talk about relationship. Now, we will not take too much time into going through the entire theory of that. Maybe we'll focus only on the important parts. So the most important part of the relation that we need to focus is that we need to understand about these three relations. That is, what is reflexive relation? Second, what is symmetric relation? And third, what is transitive relation? Now, one thing we have to note over here, when we talk about these three types of relation, then we can only say that relation for those Cartesian product which is from set A to set A. So these relations are only defined from the same set to the same set, or basically I can say that these relations have to be the subset of the Cartesian product A cross A. See, to define just relation, when we are defining just relation without any constraints, so in that case, what we talked is we talked that here A and B can be two different sets like this, and we can define it. But for these type of relations, it have to be the same set. So we'll quickly talk about what is reflexive. So the first one is reflexive. So basically, to understand or maybe basically to so that you do not forget, you can think of reflexive as reflection. So for example, let us say if I have a student, the student name is Rahul. So if Rahul is standing over here in front of the mirror, then obviously the reflection of Rahul will be what? Reflection of Rahul will be Rahul. If reflection of Rahul is something else, then I think it will make a nice story for a horror movie. But yes, reflection of Rahul will be Rahul. So this way we can understand what's reflexive relations. So we say that reflexive relation are those relations which have all the elements in the form of A comma A. That means if I have a set A which have element 1, 2, and 3, then we are saying that I want a relation. I want a relation R. We will try to other side. We want a relation R from set A to set A. That means both domain, codomain are set A. And this relationship R should have these elements. That is 1, comma 1, 2, comma 2, 2, comma 2, and 3, comma 3. It should have these elements. It can have more number of elements that we just do not care about. So it can have 1 comma 2, it can have 2 comma 3, or whatever it may be. So all these are extra. All these are extra. We just do not care about that as long as we have these three. All three of them, it's a reflexive. If any one of them is missing, if 2 comma 2 is missing, it is not reflexive. So that's the reflexive relation. Coming to symmetric. So as the name suggests, kind of symmetry we are talking about over here. So symmetric relation is very simple. Again, it's defined from the same set to same set. That means our domain and codomain have to be the same. In that case, if I have A comma B in my relationship, then I should have a B comma A. That means I should have a symmetry. If symmetry is not there, it is not symmetric. So to take an example over here, in relation R, if I have a 1 comma 2, then it is necessary that I have a 2 comma 1. It is necessary. Only then it is symmetric. If let's say I have only one of that, not the other, it is not symmetric. So in reflexive, I want everything like that. Here I do not want everything like that. I just want in pairs. As long as it's in pair, only if one pair is there, it's symmetric. I do not want all the pairs, but if they exist, they should exist in pairs. So that is about the symmetric relationship, that if we have A comma B, we should have B comma A. So for example, my relationship with my students is, okay, I can say that it is not symmetric because I'm their teacher, they are not my teacher. Although I think I'm still also in the learning phase, I learn a lot from my students. But to be precisely, if I just go by the English definition, so our relationship is not symmetric, it's asymmetric. The last one we talk about is transitive. So transitive, you can think in terms of a transition. So again, it will be only defined for the set R, which goes from the same, like relation R from set A to A. That means domain and codomain should be same. So over here we state that if in case we have a A comma B and we have a B comma C, then my relation should have A comma C to call it transitive. So the thing is, if these two exist, then this should exist. It's not like every possibility like this we do not need every possibility like that. But if these two are there, then they should happen. So it's like a transition. I'm transiting from A to B, then B to C. So I should have A to C. So that's transitive relations. Now, that relation which is all three of them, if a relation is all three of them, that means it is reflexive. it is symmetric, and if it is also transitive. In that case, that relation is called an equivalence relation. Now, equivalence relation have come many times in the board exams earlier. So that's called equivalence relation. So one example will be if I talk about set of parallel lines. If I talk about set of parallel lines, so it will be reflexive. Why? Because a line is parallel to itself. Because reflexive means I should have terms like a comma a. So if a line is parallel to itself, so parallel lines means it's a reflexive relation. Symmetric relation. If line 1 is parallel to line 2, then by default line 2 will be parallel to line 1. Now here I'm talking about only in 2D lines. We're talking about 2D lines. We're not talking about 3D. So they will be parallel. And will it be transitive? Yes, it will be transitive because if line 1 and line 2 are parallel, similarly if line 2 and line 3 are parallel, that means line 1 and line 3 will be parallel. So it's transitive as well. So this will be an equivalence relation. Now, the thing about equivalence relation, because it have also come earlier once in the board exam, so we'll talk about that. So the funda about equivalence relation is that every equivalence relation breaks the set A into three basically equivalence or equivalent sets. So every equivalence relation can break it into equivalent classes or equivalent sets, whatever you want to call it, equivalent classes. So what do I mean by it break into equivalent classes? I'll give a quick example about that. So if I have set of first 10 natural numbers, that is 1, 2, 3, 4, 5, 6, up to 10. Now, if I talk about the relationship that A minus B mod, or basically the difference of A minus B should be divisible by 3, then it's a equivalence relation. Why? Because A minus A is 0, which is divisible by 3. Similarly, if A minus B is, let's say, divisible by 3, then B minus A will also be divisible by 3. For example, if this is some 3k, this will be some minus 3k, which is still divisible. And the last one is, if A minus B is divisible by 3, let's say it's some 3k, B minus C is divisible by 3, let's say it's some 3k1, then we know A minus C will also be divisible by 3 because this will be 3 times k plus k1. So it's an equivalence relation. Now it will break into equivalence classes. What do we mean by equivalence classes? That I will say that 1, 4, 7, and 10. This is one set or one equivalent class. Similarly, I'll have 3, 6, 9 as another equivalence class. Similarly, I'll have 2, 5, 8 as another equivalent class. What do I mean by equivalent class is that if I take any two elements within these subset, I will see that they will always and always satisfy this relation. So basically within equivalence class, they are universal relation. So equivalent, actually this part is not very important. It's a very complicated theory. This comes only once, I think, but the more important parts are reflexive, symmetric, and transitive. So I think the more we discuss about theory, it will be confusing. So as the purpose of these videos is to understand through questions. So you'll understand what type of question comes in the board exams and how you are supposed to write in the board exams. And if any case you want to try on your own, you want to look more into that, all of you can pause the video for some time, think more on your own and try it out. So we'll move on to the first question that have come. You can also see that we'll have the different answer matching scheme as well, which is released by CBSE. So we are just taking the questions from the last year. So there were 4 different sets. Like I'm not talking about rearrangement of questions because that is not different set. So there were 4 different sets of CBSE 12th paper last year. So we just have taken question from over there. So this is one question that have come last year, and we'll also see the marking scheme. This is released by CBSE, official CBSE. So the question is that uh, okay, again, I'll highly encourage that all of you stop over here, read the question and attempt on your own. Do not directly jump to this. This is just for a better analysis so that you get better marks in the board exams. So the thing is, let R be the relation defined over N. N signifies the natural number over here. Okay, it's also mentioned where N is a set of natural numbers. defined as MRN. Basically, I am relating the element M to element N. That is my relation. So basically, M comma N, this ordered pair will be the part of relation. So as I've told you, when we discuss the question, we'll also explain the question well so that you can have better understanding by the time you are ready to write your board exams. So yeah, so basically MRN, if and only if M is a multiple of N. So we are saying this will only happen when M is a multiple of N, where M and N both are natural number. So what we are trying to tell is that, for example, we can have 4 comma 2, we can have a 6 comma 2, we can have a 8 comma 2, we can have a 10 comma 2, because we know that 4 is a multiple of 2, 6 is a multiple of 2, 8 is a multiple of 2, 10 is a multiple of 2. So guys, one more thing is, in the board exam, do not try to write a specific case, because this way you might not get full marks. I am doing it so that you understand the question better, because we are still in a learning phase. You understand it and make sure that you give your best in the exam. So it will be like this. So now let us look at the solution. Try to understand that how you have to express in the board exam, because that's most important. So we have to write always in a generic way. So now what we are doing is, why we are testing this out, because we know to prove reflexive relation. So we have to start with a reflexive relation. To prove reflexive relation, we have to prove that all the elements in the form of a comma a should be there. A reflection of ourselves. So that is why we are writing it like this. Let x belongs to n. X, I'm taking any element, this belongs to the natural number n. So we know that x is a multiple of itself. So every number is a multiple of itself. That means x, the relation. Now this you could have also written it in form of x comma x. It doesn't really have to be x or x. You could also write like this. Still you'll get marks. So that you can see the x comma x will be a part of the relation. Therefore, the relation R will be reflexive. Now this will give you 1 mark. So as you can see, it's a 3-mark question, because 1 mark for reflexive, 1 mark for symmetric, and 1 for transitive. So once you're done with the reflexive, you'll get 1 mark. Next comes the symmetric. In symmetric, we have talked about it, that if we have for symmetric, what we have to do? We have to say that if A comma B is part of it, then B comma A should also be part of it. So in symmetric, what we did, we said that we have 2 and 8. Both these number belongs to natural number. This symbol epsilon is called belongs to natural number. So 8 is a multiple of 2. So what we are trying to say is that 8 comma 2. Again, you need not to write like 8 or 2. You can write 8 comma 2 as well. You'll still get marks. So 8 comma 2 is a part of relation, but it's reverse. That is 2 comma 8. Or over here they are expressing it as other way around. So they're saying, but 2 is not a multiple of 8. So this is not possible, but this is possible. So there's no symmetry. Thus, it will not be symmetric. So once you get this, you get another 1 mark. And lastly, we will look for transitive. For transitive, what we are trying to do over here is, again, we'll take a set. We'll say that I have a number m. So km will be its multiple. This is fine. Similarly, I have m and some m by k. So when we do that, we can clearly see, that by transitive, what I mean is that km and m by k, they should be there, and it will be there. It will be there because it is k square times of this. So thus it will be transitive. And once you prove for transitive, you get another one. So generally the questions of relation in which you have to write this thing, you have to generally prove for reflexive, symmetric, and transitive. I will not suggest you to take examples, individual examples. Individual example might be okay if you are not proving, but for proving you should not try to do in general. So from here we are trying to do not symmetric, so it's okay. But otherwise you have to use in general. That ensures that you get more marks. So this is the one of the questions that have come earlier. Then we had case study questions from relation from the last year paper. Let's have a look at it. Also understand it how we can represent it. So the question is that a school is organizing a debate competition with participants as speakers. By the way, I've told you again and again in this video, I'm telling everything continuously. My session is, when you look at a question, pause the video, think on your own, try it out, and then Look at the solution, understand that how you are supposed to explain it. Understand how you're supposed to write it so that you get full marks in your board exams. Uh, in fact, I've been talking to many of my earlier students. In fact, they only recommended me that why can't I do this on a common video? So, because many of the students have got symptoms over the years, and this is what we want to basically convey to all of you out there. That if you do things proper, it is not that difficult to get good marks in board exams. All right, so coming back to the question, a school is organizing a debate competition with participants as speakers. So the speakers are S1, S2, S3, S4. And similarly, we have judges J1, J2, J3. Each speaker can be assigned one judge. Let R be the relation from set S to set J. We are saying a speaker X is judged by judge Y. So this is the case in which we are defining relation to a different sets. So we are defining relation from the set S of speakers to set J. So here it's different. It is so in this case, we cannot talk about reflexive, symmetric, and transitive because in reflective, symmetric, transitive, we cannot have two different sets. In Cartesian product, we need to have the same set. We need to have the same set for those three. So now coming to the questions, the question is how many relations can be there from S to J? That is the first question of the case study. So case study will be of this pattern. Generally, you'll have 1 mark, and a 2 mark question. Total of 4 marks. So the first question is how many relations are possible? So we have just now talked about it in the when we were covering this theory part quickly. That to find out relation, I need to check number of elements in Cartesian product. So if I talk about S, I have 4 speakers. Number of elements in S is 4 speakers. Number of judges are 3. So when I do S cross J, I'll have total elements in this as 12 because every speaker can be mapped to every possible judge. Now, because a set or basically a relation is nothing but a subset of the Cartesian product. So we'll just say that the possibility are 2 to the power 12. It's kind of a power set of it. So 2 power 12 directly will get number of relations. Similarly, the next part of the question is a student identify a function from S to J. Now we know function is basically a special type of relation, nothing else. So a student have identified a function S to J in which we have got S1 J1, S2 J2, S3 J2, and S4 J4. Now we have to check whether it's bijective or not. So whenever we talk about bijective means we have to look into the two categories. The two categories are whether this is one-to-one. So one-to-one separately is called injective. And similarly, we have to check for onto, which is called surjective. And if a function is both injective and surjective, it becomes bijective. So bi means two. That's what we mean over here. So onto means only one single thing, that is the range. Range means all the mapped second element. Mapped second element means it's a ordered pair. So these are the second element which are actually mapped. They're actually mapped. So that is called the set of that is called range. And what is codomain? Codomain will be the entire second element or second set, sorry. So if I have a relation R, that relation we are defining from set A to set B. So whether we are mapping the elements of set B or not doesn't matter. Entire set B is the codomain. So effectively, if entire set B is mapped, it's a onto function. And one-to-one, as the name suggests, that every element over here should be mapped to everyone. Now, if we look over here, S1 is mapped to J1, S2 is mapped to J2, S3 is mapped to J2, and S4 is mapped to J3. So we can see it's not one-to-one because S2 is also mapped to J2 and S3 is also mapped to J2. So it's a many-to-one function because two different elements are mapped to one. So S2, S3 are assigned to the same judge, so it is not one-to-one. Hence, it's not bijective. Over here, even if you prove that it's not bijective, you get 1 mark. But a more comprehensive way would have been whether you check for onto or not. Onto means all the judges should be mapped. So yes, all the judges are mapped. Judge 1, Judge 2, Judge 3. So in fact, my suggestion is you could have also written it that it's a on-to function, but not one-to-one. And if you look at the last part, so for the last section, we have two parts, that how many one-to-one functions can be there. And the second part is another student considers this relation R. In S, what is the minimum ordered pair included in R1? So that R1 is reflexive but not symmetric. So we have to talk about this also. So now what happens is for number of one-to-one functions, here we have to think in terms of like if you try to look in terms of Venn diagram, it becomes easier. So I'll do that. So because it's a set at the end of the day, we can always draw its Venn diagram, which is a graphical representation of set. So for its Venn diagram, over here I've got 4 speakers. Over here I've got 3 judges. One-to-one means every element should be mapped to 1. Now that is not possible. It's not even possible. Why it is not possible? Because there are more number of speakers than judges. So that is why it will be 0. Now coming to the last one, the question is that to make R1 reflexive and not symmetric, we need to add the following ordered pair. So reflexive means that I should judge myself. So I need to have S1, S1, S2, S2, S3, S3, S4, S4. Now, ideally, I will say that it cannot happen because I am mapping student to judges. So reflexive is only possible when I map student to student. So we can also could have said that for reflexive, it have to map from same set to same set only. When we get elements like these, it is possible. This was the 4-mark case study on the relations. Now there was one more case study. As I've told you, we have taken the different sets. That means of different questions, not just rearrangement of the questions for the last board paper, last year board paper. So the next one is a classroom teacher is keen to assess the learning of her students in the concept relation taught to them. She writes the following 5 relation, each defined on set A. This. Now defined on set A means we are talking about a relation R defining from set A to A. That means domain and codomain are the same. And this we have given these 5 relations. These 5 relations. Now we have to identify the relation which is reflexive, transitive, but not symmetric. So first of all, for it to be reflexive, I need to have all 1, 1, 2, 2, 3, 3. Reflection, reflexive. So we can clearly see that this do not have, this do not have, this do not have, this one have, and this one have. So we cannot even talk about the first for the reflexive one. Now for the symmetric, I have 1, 2 here, but not a 2, 1. That means this will be non-symmetric. So we can clearly identify it's symmetric, but it's reflexive but non-symmetric. As for transitive, I have a 1, 1, I have a 1, 2. So I do have a 1, 2 back again. I have a 1, 2, I have a 2, 2. So I do have a 1, 2. So we can clearly see it is transitive as well. So we can directly say R4 will be the case. Here in the guideline, they have directly mentioned because the explanation of these will be generally words. So what I'm trying to tell you is that you could have got the marks if you have just written R4. But again, I will suggest you against it because sometimes examiner have somewhat control over it. So better you can write R4 because you can say it's reflexive because it have all 1, 1, 2, 2, 3, 3, and it have 1, 2, but not 2, and that's why non-symmetric. Just that one statement extra if you write, it is good enough. Now coming to the next one, identify the relation which is reflexive, symmetric, but not transitive. So it should be reflexive, symmetric, and not transitive. So for reflexive, I should have a 1, 1, 2, 2, 3, 3. Now, first of all, we know that it have to be option 5 because nothing else is pending, right? Because others are not reflexive. This is out of the game because it's not symmetric. So still for a double check, because sometimes the answer might be none of them. So for a double check, we have to ensure that it should be symmetric. So I have a 1, 2, I have a 2, 1. I have a 2, 3, I have a 3, 2. That means symmetric is satisfied. For non-transitive, what we will do over here is that over here, what happens is we have to see whether there is any other possibility or we are missing out something or not. So if you look, I have a 3, 2, I have a 2, 1. So we have a 3 comma 2, we have a 2 comma 1, but we do not have a 3 comma 1. So thus it will be non-transitive, just to make it double sure. So these are the questions that have come in the last year in relation. So relation generally will be roaming around reflexive, symmetric, transitive a lot, as well as the number of relations. So I hope all of you found this video to be super useful. And if you have any further questions, you can comment below on the video. We'll also request that if in case you want me to cover anything specific, you can let us know, we'll cover that up. We just want you to do your best in board exams and get really good marks in the board exams. So that is all we wish for. So thank you all for joining and see you all in the next video.